Here's a short video explaining everything you'll need to know about the chain rule for your exams, which will definitely have some sorts of differentiation questions in it, so this may come in handy. Now, many students often consider what they learn in school to be a complete waste of time, especially in maths, when they stop and think, am I ever going to need this in my future life? So before we go into how to do the chain rule, let's consider where it's routinely used. Differentiating, and the chain rule in particular, was very useful a long time ago, helping ships navigate open waters and to avoid potential hazards. Graphs are used everywhere in the real world, from million-pound businesses to little apps on your phone that track how much you exercise. Differentiating finds gradients, which are changes in direction of graphs. So say if you want to know if your business is heading in the right direction to make a lot of money. Differentiating also helps with finding maximum and minimum points on graphs, if you want to know when you'll be making the biggest profits. To explain how the chain rule works, let's think of a basic scenario. Imagine a monkey, and for our function, let the energy of the monkey equal y. Obviously, a monkey eats to get energy, so let u equal the energy a monkey gets from a banana. And for a banana to grow, they are dependent on energy from the sun, so let's call this x. Now for this case, I'm just going to make up some equations, so let y equal u cubed, and let u equal x to the 4 plus x. So the energy of the monkey, depending on the sun, would be y equals x to the 4 plus x all cubed, remembering to substitute in your formula for u. So we want to find out how the energy of the monkey changes depending on energy from the sun, which is the difference in y over the difference in x, which is written as dy by dx. So now we need to use the chain rule. So we have our equation y equals x to the 4 plus x all cubed, and these are sometimes called functions of functions. So remember, u equals x to the 4 plus x, and y is equal to u cubed. Start by differentiating u with respect to x, giving du by dx equals 4x cubed plus 1. And then differentiate y with respect to u, which gives dy by du equals 3u squared. Now for the chain rule, we use a very simple formula to find dy by dx. So dy by dx equals dy by du times du by dx. So notice the du's will cancel. Now we've already worked out dy by du and du by dx above, so substituting them into the formula, dy by dx equals 3u squared times 4x cubed plus 1, and substitute u equals x to the 4 plus x back in, leaving u with dy by dx equals 3 times x to the 4 plus x all squared multiplied by 4x cubed plus 1. Let's have a look at an example. Take y equals 2x plus 3 to the power of 5. So let u equal 2x plus 3. Then we have y equals u to the power of 5. Du by dx equals 2, and dy by du equals 5u to the power of 4. So by the chain rule, dy by dx equals du by dx times dy by du, which gives 5u to the 4 times 2, which equals 5 times 2x plus 3 to the 4 times 2, equaling 10 2x plus 3 all to the power of 4. So let's have a look at this equation drawn out on a graph. Let's have a look at x equals 1. So we have dy by dx equals 2 times 1 plus 3 all to the power of 4 equals 6,250, which is the gradient of the curve at that point. Okay, let's have a look at a harder example. So let's take y equals 5 sine of 3x squared plus x all plus 2. So let u equal 3x squared plus x, and then du by dx will equal 6x plus 1. We then have y equals 5 sine u plus 2, and dy by du equals 5 cos u plus 0. So again, by the chain rule, dy by dx equals dy by du times du by dx, which equals 6x plus 1 times 5 cos u. So when you sub in for u, this equals 6x plus 1 times 5 cos of 3x squared plus x. So let's find a stationary point of this curve. By looking at the sketch, you can see that there's a stationary point when x is just below 0. So to find the stationary point, you put dy by dx equals 0. So that gives 6x plus 1 times 5 cos of 3x squared plus x equals 0. So by looking at it, you can see that there will be a stationary point when 6x plus 1 equals 0, therefore x equals minus a sixth is a stationary point. But bear in mind there are many other stationary points in this example, and we've only found one. Thanks for watching, and good luck with the rest of your revision.